Teach you about a magic triangle. We're going to use them throughout this course. Magic triangles are good for figuring out how to solve problems that involve three variables. And you can use this for any three variable equation in this class or any other class. A magic triangle looks like this. It's just a triangle with a T drawn in the middle. And if I write this 6 over 2, what does that mean?
6 divided by 2.
6 divided by 2. So our answer would be 3, right? Well, this line right here is this line right here. This line means divide. Okay? And it's always going to be the top number divided by one of these two bottom numbers. If I were to write this, what does that mean?
6 times 2.
6 times 2. This line right here means multiply, means times. Okay? So you can take any three variable equation, and if you set it up correctly in the magic triangle, you never have to guess about whether should I multiply, should I divide. You just plug numbers in here and the magic triangle tells you what to do. Now our three variable formula we're going to be using this week is our speed formula. And we measure speed by taking some distance, like speed in your car is 55 miles per hour. If you take some distance and divide it by a certain amount of time, you know an object's speed. Could be for big objects, small objects, fast objects, or slow objects. I'm going to put this three variable equation in here because sometimes I'm not going to ask you just to tell me the speed of something. Sometimes I'll ask you the distance. How far did an object go? If it's traveling at this speed for this long, for this amount of time. Maybe you have to solve for distance. Sometimes you'll have to solve for time. Okay? So in this magic triangle, I want to set it up correctly. And this line right here is this one. So what goes on top? Distance. So I'm going to put distance on top. Time goes beneath that. I'm just going to put it right here. Doesn't really matter which side I put it on. And then speed would fill our last spot. Okay. What kind of units would we have for distance? When we're measuring kilometers,
Miles,
Meters, centimeters,
millimeters, decimeters.
Yep, all of those. Meters, right?
meter.
Yeah, for science, we want to try to stick with kilometers, meters, centimeters, something in the metric system, but you could also put feet, miles, inches on there as well. So there are some examples of the units that we'd have for distance. What units do we use for time?
Seconds, days, hours.
Right.
Hours.
Usually for us it's going to be probably seconds or hours, but there are other ones you could put in here. So now if these are my units, what kind of units do I have for speed? Speed in your car is what?
Miles per
Miles per
hour. Kilometers per hour.
Right, in the metric system, literally we're taking kilometers dividing by hours, or you could do kilometers divided by seconds, kilometers per second, meters per second, centimeters per second, centimeters per hour. Isn't it kind of weird that you're doing the exact same thing with the letters as you are with the numbers? Okay, so depending on what units you have, it could be, I'm just going to put a couple of examples here. These are called derived units. They're the result of doing some math. So kilometers per hour, meters per second, those are two common ones that we're going to use, and of course there are lots others. So when you're reading a story problem and trying to solve for speed, time or distance, You can just plug numbers into the magic triangle. I always want you guys to show your work somehow. And I know that some of you are totally cool with plugging numbers into the formula and solving that way. That's fine. This is just another option for students who struggle with algebra a little bit. And it's one way to make sure you're getting the correct answer. Let's take a look at what that looks like on our worksheet. So on this assignment, I want you to solve the following speed problems. You can use the triangle to help you solve the problems if you want to. I always want you to show your work. How did you get your answer? Okay? And some students who like using the triangle actually just draw the triangle. Okay? And then they just plug in their values. Look at the numbers that we have available here. 125 kilometers and 2 hours. Where would 125 kilometers go? Top, left, or right? 125 kilometers, that's a distance, so it goes on top. So I'm going to just write in 125 kilometers. Where does the 2 hours go?
Times of 5.
Yep. So I'm going to put 2 hours down here. Remember, this means times, this means divide. How do I get this answer right here?
Divide 125 by 2.
Right. You always want to punch in the top number first. 125 divided by 2, which is 62 point something. You guys can round off wherever you want. For me, I don't care very much right now. So it's about 62 point what? 0.5. And what do we write on there for units? Can't forget the units. No naked numbers.
Oh, that's in 2 hours. Whoops.
Kilometers per hour. There's our final answer. 62.5 kilometers per hour. Let's try the next one. Baseball is thrown 20 meters. What is that? Distance, speed, or time?
Distance.
20 meters is a distance. And what is the speed? That's what we're looking for. This is a time again, so 0.5 seconds. You just take 20 divided by 0.5, which is 40 what?
40 meters per second.
Meters per second. You have to remember your units. Guys, if you don't have the right units for me, you can round wherever you want, but if you don't have the right units for me, or you're not showing your work, you don't get credit for it.
Do you have to show or do the units on the answer and like your work, or just the answer?
It definitely needs to be the correct units on your answer. So like if you just wrote 20 and 0.5 here, that's okay, but I really encourage, if you have trouble with algebra, include your units on there. It just takes a second, and it shows you exactly where those derived units come from. Meters over seconds, meters over seconds. Let's try one where we're not calculating speed now. How much time, number 3, how much time does it take for a bird flying at a speed of 45 kilometers per hour to travel a distance of 1,800 kilometers?
4 hours.
How did you get that?
So I multiplied my speed by my time. I divided my distance I divided my distance by my speed, which when I was doing the math came out to 4. So I got 4 hours.
So where did you, in our triangle, where did you put 45 kilometers?
45 kilometers per hour goes to speed.
That's a speed, isn't it? It's not just 45 kilometers. It's 45 kilometers per hour. So that's our speed, and it would go down here, right?
Yeah.
45 kilometers per hour.
Then at the top I put my 1,800 kilometers.
There you go.
Then
Then you just,
and I got 4
1800 divided by 45. 40.
I was off by. I did up all the way to the so I could do it with 45, and I had Joseph Kabbalah after divided by 4.
Okay, so what kind of label did we put on this?
Hours.
Yeah, it needs to be a time, and the only time I see here available is in hours. Okay? And there's your answer, and you want to circle your answer so I know which one you're working out, please. I want you to try the rest of these, and I am going to write down the answers for these here so that you, as you're working, can see if you're doing them correctly. All right, here are your answers. Number 10 should be 25 seconds. Number 11, if you read the question carefully, you had to figure out how much over the speed limit she was actually going. And your answer would be 65 kilometers per hour over the limit. And number 12 is 4 centimeters per second. If you didn't get done yet, I'll keep this answer key up here so you can look back at it. Just a reminder, any work from last week is due into me by midnight tomorrow night.
570 only goes 53.
Just make sure you know how to do these because
424 tracks.
next week you're going to have a quiz over this. You don't know how to do number 11?
Everything else is 19.
Very, very.
Okay. Parker, how did we get 65 kilometers per hour over the limit?
I'm a slow worker on these, and I'm only on question 9.
That's all right. You're doing good.
Well, not everybody can bring it like you can.
So what they're giving us here is some extra information. This time we have 3 numbers. We have 60 kilometers per hour, we have 10 kilometers, and we have 5 minutes. They're just telling us here that Lauren's SUV was exceeding the posted speed limit of 60 kilometers per hour. So that's the speed limit. She was going faster than that. How fast was she going if she was doing 10 kilometers in 5 minutes? Here's our speed triangle. She's going pretty fast. So speed is what we're looking for. We have 10 kilometers. That goes on top. 10 kilometers. Now it says in 5 minutes. Now wait a second. If we put 5 in here, we're going to get 2. Do you think she's really going at a speed of 2?
No.
She's going 2 kilometers per second.
Ooh, that makes
We want to compare it to kilometers per hour. So if we wanted to change 5 minutes
into 50.
into what?
I have a math problem, so I just said a random number.
If we wanted to change 5 minutes into hours, is it more than 1 hour or less than 1 hour? Five minutes, is it more than 1 hour or less? Way less, right? So it's going to be some fraction of an hour. So are we going to multiply by 60 or divide?
Multiply.
If we multiply 5 times 60, we're going to get a really big number.
Wait. That's only. Okay, yeah.
So it'd be 5 minutes divided by 60. You should get 0.08. So now it's hours. So your final answer, how fast was, or not your final answer, but your answer as to how fast she was going, she was doing 125 kilometers per hour.
It's actually not that fast. That's only like 60.
70 miles an hour? That's like 70 miles an hour.
How much over the speed limit is she going? If the speed limit's 60,
65.
65 over.